Good evening, all. On the occasion of 105th birth anniversary celebrations of great mathematician Dr. Komarolu Chandrasekharan Garu and 71st birth anniversary celebrations of our former head of the department, Dr. Nagala Prabhakar Rao Garu, the Department of Mathematics is organizing a one-week international faculty development program on innovative applications of mathematics, IAM 2025, in association with the Institution's Innovation Council, ICC-BAC. On the first day, Dr. P.V. Sundarananda Garu, Professor and Head Department of Mathematics, Rayalaseema University, Kurnool, has delivered a talk on randomness and essential for security. On the second day, Dr. C. Pavan Kumar Garu, Faculty in Mathematics, Apex Max Excel Center, North Carolina, USA, delivered a talk on applications of linear algebra, matrices, least squares. On the third day, Dr. G. Srinivas Rao Garu, Professor, Department of Mathematics and Statistics, University of Dodoma, Tanzania, has delivered a talk on basic statistics and nonlinear optimization using R. On the fourth day, Dr. Fanikumar Garu, Professor and Head, Department of Mathematics, Vasvi College of Engineering, Hyderabad, has delivered a talk on mathematics behind disease transmission from SIR model to real-world epidemics. On the fifth day, that is yesterday, Dr. J. Bhaskar Babuji Garu, Professor, Department of Applied Science and Humanities, Anna University, MIT Campus, Chennai, has delivered a talk on automata theory in machine learning. For all the above 5 days, each session is engaged with approximately 700 participants. Thank you, one and all, for your good response and valuable support. Today is the final day of a one-week faculty development program, and today's speaker is Dr. Koti NVV Varaprasad Garu, Associate Professor, Department of Mathematics, Guru Gastas Viswavidyalaya, a Central University Bilaspur, will deliver a talk on the stability of some fixed point procedures. Now I request one of our staff organizers, Ms. K. Sunita, to present profound profile of Varaprasad Garu.
Good evening all. Welcome you all to a one-week international faculty development program on innovative applications of mathematics. I am honored to introduce today's resource person, Dr. Koti N. V.V. Varaprasad sir. Dr. Koti N. V.V. Varaprasad sir is an associate professor working in the Department of Mathematics in Guru Ghasidas Viswavidyalaya, Bhopal, a central university in Bilaspur. He did his MSc in Mathematics from Bapatla Viswavidyalaya, MPhil from University of Madras, Chennai, and PhD from Andhra University, Visakhapatnam. He has published 21 research papers in various reputed international journals. 2 students have obtained PhD and 2 are pursuing their PhD under the guidance of Dr. Varaprasad Garu. He completed 1 project sponsored by UGC of worth 6 lakhs. He delivered invited talks in various national and international conferences. He is a life member in various mathematical societies. Presently, Dr. Varaprasad Garu is working in the area of nonlinear analysis, fixed point theory and applications. Dr. Varaprasad sir is praised by one and all for his best way of teaching from the last 3 decades. His soft nature, motivational behavior, teaching abilities, research capabilities are additional strengths to him apart from his goodness and vast experience in the field of education and research.
Thank you, Sunita, for your nice introduction about Dr. Koti NVV Varaprasad Garu. Now I hand over the session to Dr. Koti NVV Prasad Garu to deliver his lecture on the stability of some fixed point procedures. Sir, please start the session, sir.
Thank you very much, sir. Thank you very much for introducing me. So it is in the department, there is not an updated version of my personal details. It was increased in research papers in 45. And one more student is submitted and awarded also PhD degree. Wonderful. And 15 students are projected in MSc level. Thank you very much, sir, for giving me an opportunity. And I would like to start with my topic. In today's in my presentation, the title of my title is that on the stability of fixed point iteration procedures. My research area is a non-linear analysis. Recently, I'm doing research in stability theory and some applications in iteration processes also. It is a innovative research area. So we are studying some stabilities with using some iteration procedures. So first of all, before going to be start the stability concept, I would like to give you some introduction. About the fixed point theory. So first of all, I would like to start with my introduction. So generally, in this presentation, I collected some important iteration schemes. That is a Mann iteration and Ishikawa iteration and a Noor iteration and Sahu iterations. I would like to change the voice. Here it is voice is very low. Please, thank you very much. Okay. Some iterations. So first of all, I would like to give it to you. After that, would like to discuss with the relations between some iterations, why these such iterations is needed. And also we are going to be discuss with the some important stabilities. Out of 3 or 4 stabilities, I am discussing only the 2 stabilities only, that is the Russ and Harder, and using the primary iteration procedures with using of some contractive conditions also and relations also. I'm going to be given some examples also, supporting of our main results and the comparison of the results also. And in this literature, plenty of iteration procedures also introduced. Mainly, I collected some of the iteration procedures only. Before going to be go for the iteration procedures, I would like to give us some little bit introduction about the fixed point theory and Banach contraction principle, some others. So first of all, I would like to ask you first some basics and the concepts. That is, everybody knows that. What is the fixed point? This thing is very well known. I would like to give a definition here. Maybe it is useful to us also. Everybody knows that this definition. Suppose let us take an X is an analytic set that the mapping T is a self map. And we can say that X belongs to X and is a fixed point of T if you are taking Tx is equal to X. And it is also more examples also adjusted in general mapping results also. I would like to provide for our convenience, for understanding purpose, I am giving some examples. Here it is, suppose if your X is a R and T is a self map on R to R and Tx is equal to X square plus 5X plus 4. If you are considered this is the f of T is equal to minus 2 is a singleton set, that is minus 2 is a fixed. I think so. It is wrong first length. Second example, first like the X square minus X. In this, if you are solving of this equation, f of T is equal to 2 numbers, that is a 0 and 2 are 2 fixed points. And similarly, if you are taking a Tx is equal to X plus 2, there is no fixed points in this example. And the last example, Tx is equal to X, then every point is also in fixed point. If you are observing this one, that means in our mappings, there is some fixed points also adjusted. There is no fixed points, more than one fixed points also adjusted. Such type of examples also easily we can find out. Suppose let us take it some iteration procedure also we are going to be introduced here. Let us X is a non-empty set and T is the self maps on X to X. And any initial value, that is X belongs to X, and define T power N of X inductively. T power naught of X is equal to X, T power N plus 1 of X is equal to T of T power N of X. Suppose if you are continuing this manner, we can write it. This is a pattern. Xn is equal to Txn minus 1 is equal to T power N X naught. Also, we can write it as our convenience to the solution of the problems. This type of iteration is called, actually, this is a Picard iteration with using a starting initial value with X naught. And before going to go for the one of the important theorem, that is the Banach contraction principle, I would like to give a one known definition, that is the Lipschitz constant definition mapping theorem. Let X be a metric space and a mapping T is a self map on X. And if there is this L is greater than 0, such that D of Tx will less than equal to L times of D of Xy for all Xy in X, then L is called Lipschitz constant. In particularly, if you are taking L is equal to 1, this is condition is called a non-expansive. If it is L less than 1, then T is a contraction. And if it is L is equal to 0, suppose actually L is a positive, if L is equal to 0, then automatically this T is a constant mapping. This is the one of the important definition. Now we go for the main one of the famous theorem, the most significant and remarkable result due to the Banach, that is called Banach contraction principle. So I would like to read it out, that the Banach contraction principle theorem. Let T be a self map on a complete metric space XD, and T satisfying the contraction condition D of Tx less than equal to H times of D of Xy, and H is belongs to semi-interval 0 to 1. And for any X1X, then T has a fixed point in X. This is called Banach contraction condition, in fact. So this is a very famous, it is actually Banach is discovered this theorem, and in his PhD thesis it is adjusted. This is the famous theorem. And after that also, in nonlinear analysis, especially fixed point is turns a very drastic changes. And we can find the Banach contraction theorem is generalized mainly by changing the one or more than of one following points also. Sometimes spaces also they are changing. And mapping, and that means the contraction conditions are generalized. And iteration schemes also they are going to be changed. In fact, in the proof of the Banach contraction principle, after taking the initial value, there is a skeleton. The skeleton of the proof is that first of all, construct the sequence, and you go for the decreasing sequence and show that the Cauchy sequence, then converges to a sequence is the convergence, and then they are going to be used with using of contraction condition. T has a fixed point, unique fixed point, and also it is one of the observation T forced to be continuous. This is the one of the drawback. After that also there is a another direction is also research is also continuous going on, and also still it is also interesting manner whether it is a T is a discontinuous is possible or not. That last time also I think so previous year I gave a lecture in this same platform and in this direction. There is the discontinuity points also. So now this time I am going to be use the iteration scheme concept. Therefore, I would like to leave that continuous and discontinuous concept. Especially in, I am using the iteration, changing in the iteration schemes only. Before going to in that direction, I would like to start with the Picard iteration, because the Banach contraction principle, mainly he used the Banach Picard iteration only. Actually, because sometimes the Picard iteration need not be converged to any fixed point of T if T is a non-expansive map. Even if the set of fixed points is a non-empty, so other iteration schemes are used to approximate the fixed points of different kind of maps. sometimes Picard iteration may not be converged. That means, so suppose I'm not given that one example here. So please listen carefully. Let us take it x is equal to 0 to 1. Because unfortunately, I am unable to write on the board here. Therefore, please observe that carefully. If you are taking capital range is a domain. Domain is a x equal to 0 to 1. And mapping is defined tx is equal to 1 minus x. Then if you are taking any initial value, it cannot be converged to the required point, required iteration convergent does not converges. If you are using the Picard iteration, suppose x naught is a 3 by 4, 1 minus 3 by 4 is a 1 by 4. Once again 1 by 4, if you are substituting, then it will become 3 by 4. Already in the second slide, I mentioned the Picard iteration scheme also. Tx naught is equal to x1, T of T4 n of x naught equal to xn plus 1, some like that. Therefore, there is some examples also adjusted. Picard iteration does not converges. Therefore, Picard for reducing of the for getting the convergence, Picard iteration is not useful. Therefore, one iteration is generated. Later that it will be developed also. Before going to be enter that main concept, I would like to hear also the various contraction principle generalizations in the following two ways. By beginning the contractive properties of the map, by extending the structure of the other spaces also. I am going to be touch these three sections also with using of iteration schemes. So mainly I would like to this is the first iteration. First, I would like to discuss with the Picard iteration. This is already I discussed it just 2 minutes back. That is the Picard iteration. In 1890, Picard defined the iteration scheme. That is X to be a metric space, and D is a closed subset of X, and D is a self map on D, at least one fixed point, and a capital F of T, that means of a set of collection of all fixed points of T. For given a x naught in X, x naught is an initial value, and considering a xn, determine the successive iteration method that is mentioned here, xn is equal to txn minus 1. It is also can be written as t power n of x naught. I gave just 2 minutes back one example for this Picard iteration. That example, tx is equal to 1 minus x, Picard iteration does not converge us. For the purpose for getting the convergence, there is a one iteration is needed, and it was established in 1953. Defined the following iterative method, the class of non-expansive operators. That is the xn plus 1 is equal to 1 minus alpha n, xn plus alpha n txn. And alpha n is belongings to interval 0 to 1. And if you are taking in this alpha n is equal to 1. If you are taking one iteration alpha n is equal to 1, then automatically the first term in the right hand side is vanishes. Xn plus 1 is equal to txn. Automatically one iteration is reduces to the Picard iteration. Therefore, it will be major class, generalized of the Picard iteration. And one more observation is also needed, and it is also not mentioned in my slide. If you are taking in place of alpha n is a one constant lambda. So I would like to read out that equation here. Xn plus 1 is equal to 1 minus lambda xn plus lambda into txn, where lambda is this interval between 0 to 1. So that iteration is called a Krasnodębski iteration. So that is also very famous also. After that also in place of lambda, we can write it any sequence of alpha n. It is mentioned here. After that, there is a one example also adjusted. The example is not mentioned here. Such one example is also mentioned. That example does not converge whether it is using a Picard and monetization also. So in that purpose, this iteration, what I am showing in the screen, that is called a Ishikawa iteration, it is essential. So it is a very famous iteration in this literature. That is the Ishikawa iteration. This Ishikawa iteration was introduced by Ishikawa in 1974, and it was published in the Proceedings of American Mathematical Society. This iteration is mentioned is defined by xn plus 1 is equal to 1 minus alpha in xn plus alpha in tyn, and yn is a 1 minus beta in xn plus beta in txn. Actually, here it is a tyn is typed. It is a typographical mistake. Kindly read it out. That is a txn. Especially alpha and beta n should be 0 to 1. But it is mentioned it is a 0 to 0. So kindly excuse and make it is a right hand side is a 1. So it is the Ishikawa iteration is also very interesting also. Particularly if you are taking beta n equal to 0, then Ishikawa iteration reduces to the Mann iteration. So in Mann iteration is already mentioned how it will be reduces to the Picard iteration also. There is an implication also. In that means Mann iteration is also one of the cases of the Ishikawa iteration. Picard iteration is also one of the cases of the Mann iteration. Actually, these three are very famous in this, especially in the iteration processes in fixed point theory. After that, there is one mathematician that he is called discovered in 2000 new iteration, and that means the third iteration process also he introduced. But there is no example in the literature which is not failed in the Ishikawa iteration. No iteration will be essential, but it is a continuously it is useful also. Later also I will explain how it will be useful. So in this iteration is mentioned here, particularly in skeleton is I am giving here. Xn plus 1 is equal to 1 minus alpha in xn plus alpha in tyn. Yn is equal to 1 minus beta in xn plus beta in tzn. And zn is equal to 1 minus gamma in xn plus gamma into txn. There is a one query is also existed in the researchers. How many times how many times going to be iterated these steps? So that means first of all, Picard is a one line, that is a one step iteration. Mann iteration is a two step iteration, and Mann iteration is a one step iteration. Ishikawa iteration is a two step iteration, and a new iteration is a three step iteration. If you continue on the fourth step and fifth step also, if you are introduced, that is the nothing to variation between new iteration and new thing also. If you are increase the step, one more step, that means xn plus 1 and yn, zn and en or whatever, that is not a useful. So therefore here it is some examples also existed in the literature also. They mentioned it more than 3 is not necessary to increase the steps also. But there is some mathematicians also developed some literature. Some other iterations also introduced. That I identified some iterations here. That is also very most important, especially the researchers also. But first time those who are listening to these iterations may be confused. So listen carefully also. Later also, if you have any information needed, then you can call to me according to through email. Then I will service you. And I would like, my intention is that, especially in this research area, plenty of iteration processes also published and developed. They are also given a importance also. I am also going to be giving importance in this presentation also later after completion of the introducing of the all iteration procedures. Why it is needed. So first of all, I would like after no iteration, there is some iterations also existed and very famous also. Yes, iteration scheme. R.P. Agarwal, Florida Institute of Technology Senior Most Professor. All researchers also, they know that he is a very famous mathematician also. After Lakshmikantam, he is a founder of the Journal of Mathematical Analysis and Applications, Non-Linear Analysis and Applications editor. He published in one research paper in 2007. Here it is xn plus 1. There is a typographical mistake here. So in first term, there is no ty n. In fact, actually, xn plus 1 is equal to alpha and xn plus 1 minus alpha and txn. And yn is equal to 1 minus beta and xn plus beta and tyn. If you looks like one iteration and Ishikawa iteration and this iteration will be same. Looks like only same only, but this is differ also. Kindly note it out. This xn tyn is not adjusted. What I am copying here, that is not adjusted in this equation. And xn yn is equal to 1 minus beta and xn plus beta and tyn. If you are taking any example with using of the Ishikawa iteration and S iteration scheme, definitely for converging fixed point, reaching the fastness is the S iteration scheme is very needed. If you are applying Ishikawa iteration, converging to the fixed point, number of steps will be high and S iteration scheme will be low. He mentioned in 2007 the importance of this iteration scheme. Like that, many of mathematicians also is also mentioned here also. I think approximately I am providing here at nearest 15 to 20 iteration schemes. Depend upon those who are interested to do this scheme, they can find out which one is useful to you according to your provided contraction condition. So now it has come to the point in 2011, SP iteration scheme. This is also looks like in Noor iteration scheme type only. That is xn plus 1 is equal to 1 minus alpha and yn, alpha and tyn. Yn is equal to 1 minus beta and zn and tzn. And zn is equal to 1 minus gamma and xn plus gamma and txn. So here it is there is a changes here, especially what I'm copying here, yn and zn, and here it is a tzn. These also in 2011, he mentioned why it is importance also. Now, I would like to, especially CR iteration scheme, Chow and all in 2012. Looks like it is a same also in the previous iteration. There is some changes. T is mapping is introduced here. And Thakur iteration, Deepthi Thakur, it was in 2014. And xn plus 1 is equal to 1 minus alpha and txn plus alpha and tyn. Yn is equal to 1 minus beta and zn plus beta and tzn. Zn is equal to 1 minus gamma and xn plus gamma and txn. So first of all, people need to understand that what is the importance about these iterations also. So suppose I am saying that in 2014 paper and D Thakur iteration scheme also he provides. There is some examples also adjusted. What I mentioned in previous slides, if you are using that iteration scheme and with that example, converging the fixed point will be very high. High means the number of steps will be very increased. If we use a Thakur iteration, it will be converges to the fixed point is a very less number of iterations is needed. That he mentioned that this iteration scheme importance also. And in every paper also, they mentioned it like that only. Abbas and Nazir iteration scheme in 2014 also, it is also mentioned the same thing also. But here it is everything is mentioned. And they are also mentioned here. And Watten iteration This is the very famous iteration. This is the one of the famous iteration, and also I am going to be use this type of iteration for using of the Rust and harder stability schemes also. So first of all, I would like to mention this is xn plus 1. T 1 minus alpha and yn plus alpha and tyn. Second, yn is equal to t of 1 minus beta and xn plus beta and tzn. So therefore, if you are taking T is a identity mapping, automatically it will be reduced to the Mann iteration also. And he mentioned it is the convergence, relations between the Mann and Watten iterations also. Unfortunately, this I would like to stop the sharing and I would like to show the another part. Share, okay. Sorry for the break. The one of the famous iteration, this is the B.S. Thakur. He is a mathematician in Ravi Shankar Shukla University, Raipur. And it was published in Philomat. So I given here it is xn plus 1 is equal to 1 minus alpha and tzn and alpha and tyn. Zn equal to 1 minus beta and zn plus beta and tzn. Yn is equal to 1 minus gamma and xn plus gamma and txn. This is the he introduced and he gave us an importance and why it is a needed. T.S. Thakur is also once again he established one more iteration scheme also. This is the two-step iteration. And if you are observing here, I would like to read it out from bottom to top. First one is xn plus 1 is equal to tyn. In fact, this step is called a Picard iteration method. Second is the yn is equal to t of 1 minus alpha and xn, alpha and tzn. This is a Watten type of iteration scheme. Zn is equal to 1 minus beta and xn plus beta and txn. This is a Mann iteration scheme also. Sometimes it is called one-step and two-step iterations also we are calling here. And in 2018, K-star iterations also given here. Both are also same, but convergence of, alpha and beta and notations is different. Next, if you are taking the Ulla and Arshad 2018 published paper, and if you are observing this one is that xn plus 1 and yn both are Picard type of iteration. Zn is equal to 1 minus alpha and xn plus alpha and txn iteration. We are calling here two-step Picard, one-step Mann iteration scheme also. With this, they are calling like this also. Xn plus 1 is a Picard method, yn is also Picard type, Zn is a Mann type. And also he is also given he also importance of with examples also important rate of convergence also. And K iteration scheme in 2018. This is also same. And xn plus 1 is a Picard type. Rest of the part is a Ishikawa type. But here it is there is some only one variation is that this is T is additional only. In especially what I copied on the board, yn is equal to 1 minus beta and t xn plus beta and tzn. This is the another iteration. And Jung's iterative. That is a 2019. Here it is xn plus 1 is equal to tyn. Yn is equal to t of alpha and zn plus 1 minus alpha and tzn. Zn is equal to t of beta and xn plus 1 minus beta and txn. First one is a Picard type. Second and third, that is the Watten type curve. Next is Picard S hybrid type iteration. that is xn plus 1 is a tyn, and yn is equal to 1 minus alpha and txn plus alpha and tzn, zn equal to 1 minus beta and xn plus beta and txn. If you are observing of this iteration and the top one iteration also, there is a t is not there only, that is the difference. So he mentioned it in this paper also with the using of very interesting examples also, why it is needed, why it is not needed at t also. And Javed Ali, he is associate professor in the Aligarh Muslim University. It is he's taking a very simple iteration, two-step Picard iteration. One is the Mann iteration, Mann iteration with using of the additional T mapping. And he published in paper also with using of examples, especially rate of convergence, why it is needed, why it is not needed, the rest of the part also. So it may be relations between the node relation scheme also, particularly he mentioned it, and relations also mentioned in his paper, and with examples also, and rate of convergence also he provided in that paper also, why it is needed. Now this is the S star iteration scheme. Xn plus 1 is equal to 1 minus alpha and yn plus alpha and tyn. Yn is equal to t of 1 minus beta and zn plus beta and tzn. Zn is equal to t of 1 minus gamma and wn plus gamma and twn, and wn is equal to t of 1 minus delta and xn plus delta and txn. In fact, this much of iteration is not needed. In this paper also he mentioned it everything, but it is not that much of importance. It is not needed also. Very particularly cases, especially proximity type of iteration schemes also he used in this paper also. And JF iteration, if you are observing here, xn plus 1 is a Watten type ka, yn is a Picard type, zn is a Watten type. And the plus iteration scheme, Danish Ali, he is also same thing, and it is he applied in a new iteration scheme as it is here, except it is repeated when where I am copying. Here it is only. The rest of the part, if you remove the t, automatically it is nothing but it is a new iteration scheme. What is this iteration scheme is that zn is equal to t of 1 minus alpha and xn plus alpha and txn, and yn is equal to t of 1 minus beta and zn plus beta and tzn. Xn plus 1 is equal to t of 1 minus gamma and tzn plus gamma and ty. Now, before going to be go for the importance of this thing, I provided in this talk approximately 15 to 20, approximately 18 iteration schemes I mentioned. For purpose is that this much of iterations also available in literature. Especially, these are not iteration schemes are not necessary for getting the convergent of the fixed point. So one is Picard, Mann and Ishikawa iterations only, but it is needed for getting the rate of convergence, time to time, problem to problem. Iteration schemes also very essentially introduced. So how to find out the iteration scheme is a fast rate of convergence is a fast that he developed, and Vasily Birinde is developed one with one definition. Before he developed the definition, he wrote, he published on research paper better convergence only. But recently in 2000, approximately 2005 or 6, he published on research paper in the fixed point theory and applications. Later on, that journal is also his name was changed, and so publishers also changed also. Now I would like to introduce. This is the Vasily Birinde's definition. So I would like to read it out. This is the very most important. Why these iteration schemes are necessarily important means with using of this definition only. Let AN and BN be two sequences of real numbers converging to A and B respectively. That means of AN is converges to A, BN is converges to B. If limit n tends to infinity, that fraction, that means of modulus of AN minus A by modulus of BN minus B is equal to 0, then we comes to conclude that AN converges to faster than BN. This is the definition. And one more definition is that let us Xn and Un be two fixed point iteration procedures associated with a mapping T. Let both be converging to a fixed point of P of T with the following error. That means of norm Xn minus P less than or equal to An, norm Un minus P less than or equal to Bn. Then if An converges to faster than Bn, then Xn converges to the faster than Un according to the above definition. We can say that this is the point only. So the following, just for that for identification purpose only, if the following two inequalities are known for some k1, k2 with k1 less than k2, that means of xn plus 1 minus norm xn plus 1 minus p less than or equal to k1 into norm xn minus p, norm un plus 1 minus p less than or equal to k2 into norm un minus p. Then we can take that ratio and taking as n tends to infinity. If it is 0, then it comes to the xn converges to faster than un. And so to compare the rate of convergence, it is sufficient to compare the values of k1 and k2 in the above two equations. So suppose if you are taking any contractive condition, if it is already adjusted a fixed point. So for getting the fixed point, maybe that mathematician may use one iteration scheme, and another mathematician may use Ishikawa iteration scheme. And virtually it's same, both iterations also converges to the same fixed point. Then if you are applying this definition, then you can identify that which one is going fast. Which one is a less iterations is needed for getting a fixed point. This is the very most important present. It is research is going on in this area for getting a less number of iterations only. If you are converging to the fixed point, then it is a very useful. Then so that this purpose only the above all iteration process is also introduced. So that means we cannot conclude the one of the iteration scheme is a very good. Depend upon the problem and depend upon the situation. Sometimes some iteration may fast, sometimes second iteration may be fast. Depend upon the situation only we can identify that which iteration is a good. Suppose let us take it. This is that I think this is not necessary. I would like to stop it this now. This is now I will come to the my concept, especially not in this area. That is this concept of the stability. First of all, this stability concept is introduced in 1988, especially in the nonlinear and fixed point theory area. I would like to introduce and read it out. This definition, that is let us clearly observe here. Suppose Xn be a sequence in a normal linear space X and X be a non-empty closed convex structured by iteration scheme. Xn plus 1 is equal to f of t xn, where x naught is belongs to k, xn converges to a fixed point of t. Now we would like to say that this iteration process t is stable. if for any arbitrary sequence yn and x, lim tends to infinity epsilon n is equal to 0. If and only if lim tends to infinity yn is equal to p, where epsilon n equal to norm yn plus 1 minus f of t yn for n is equal to 0, 1, 2 up to so on. Here it is I mentioned is a 4 equation number 4. Xn plus 1 is equal to f of t comma xn. F of t comma xn means that f is a function. It is involves two terms, that is mapping and xn. That is depend upon the situation. If it is, you can write it to f of t comma xn may be Picard, otherwise man, otherwise Ishikawa also. If it is a Picard, we can say that it is a T stable. If it is a man, then man iteration T stable. If it is Ishikawa, Ishikawa iteration T stable. So first of all, I would like to say that only it is a T stable only. Please understand that f of t comma xn is not nothing but a new iteration scheme. It is a depend upon the situation. It is a defined iteration scheme. Depend upon the problem only, it will be name will be changed. And Harder and Hicks is also introduced this iteration scheme in his PhD thesis. Harder and Hicks proved in their paper that Picard iteration is a T stable with respect to the alpha contraction and Jomfirescu mapping. The Jomfirescu mapping is also very well known, and I would like to give a few introduction about the a small introduction about the Jomfirescu mapping. Generally, after Picard Banach contraction principle, we know already there is some history. Once already in the starting lesson, T is a force to be continuous. For avoiding the continuous, Kannan and Chatterjee is also avoid the difficulty. And these two persons is also, mathematicians also provided a fixed points. That is discontinuity mappings. Previous talking at previous talk, I gave this introduction also. Including of these three contraction mappings, Jomfirescu is developed one fixed point theorem. That is mapping is called as Jomfirescu mapping. Now, after that, for relaxation of the generalize the Jomfirescu mapping, Voselike, a broader form of contractive condition is introduced. That is mentioned here as a question number 5, equation number 5. Norm Tx minus Ty less than or equal to delta times of norm x minus y plus L times norm x minus Tx. And proved that stability results for Picard and Ishikawa iterations also. That means Voselike is also proved the stability results with using of the Picard iteration as well as the Ishikawa iteration also. After that, Imiru and Voltanivo established the harder stability of the Picard and Mann iteration procedure by extending the Voselike's results also, and with using of the some function. The condition, consider of the following contraction condition, there is a constant delta lies between 0 to 1 and monotonic increasing and continuous function phi is r plus to r plus with phi is vanishes at 0 such that norm Tx minus Ty less than or equal to delta times norm x minus y plus the phi of x minus Tx for all x, y and x. So this is inequality is called a 6. In fact, inequality 5 is a subclass of the 6 also. That means if phi of x minus Tx, phi of x is equal to Lx, automatically 6 is reduced to the 5. Therefore, inequality 6 is a generalization of the 5. Now, after that, Russ is also introduced a new type of iteration scheme. That is introduced the limit shadowing property. This was adopted by the Russ and in order to introduce a new concept of stability for fixed point iteration procedure, which is more general than the stability introduced by Harder. Now come to the main part, especially Tim is and GVR Babu and Satyanarayana adopted the limit shorting property and the concept of the Russell stability to prove the stability results of Picard and Money iteration methods respectively. And it is these results also very interesting. And also I developed some schemes also. Now we studied and wrestled harder stabilities of the iteration procedures, Ishikawa iteration procedures through the contractor condition 3 in the setting of the normal linear space. Condition 3 I would like to show to you. It is needed to remember. This is 6. 6 and 3 is also same. And for any arbitrary sequence Pn in X is satisfying, limit n tends to infinity norm Pn minus f of t comma Pxn. And it is implies that there is x naught in X such that limit n tends to infinity norm Pn minus Xn equal to 0. You please observe that, and here it is mentioned the f of t comma Pn, and in this particularly this is a Ishikawa iteration scheme. Ishikawa iteration scheme already I mentioned in the previous just 20 minutes back what is the iteration scheme. I am unable to show it now. I think we can understand that Ishikawa iteration step, that is 2-step of iteration scheme. Now it is a Ishikawa iteration procedure is said to be stable in the sense of Rus with respect to an operator T if it is a convergent with respect to the T and that operator T has a limit sharding property. And lemma 1 is also needed for getting the convergence. Therefore, I mentioned it here only. It is a very essential for getting the convergence of the convergence to the fixed point. I am using as a tool. Therefore, I mentioned it here. Now comparing analysis. This is the very the Babu and Satyanarayana results is inspiring me, and also I am also developed these results also. This is the very most important result also. Let K be a non-empty closed convex subset of a normal linear space. T is a self map on K. Be a self map of K, and f of T means that collection of all fixed points of T is non-empty. Let alpha and beta in be two sequences lies between semi-interval 0, 1 and x0 is the initial value. We assume that Ishikawa iteration converges to a fixed point of P. And it is a T stable, then T has a unique fixed point. So this is the one of the proposition. And that is how we are going to be here also with using of the stable definition. So I mentioned it is a previous slide. I would like to go for the previous slide. Here it is. I'm copying here. This is. In this copying f of t comma pn is adjusted. Now, here it is I mentioned here. This is the Ishikawa iteration procedure. Let us see be a fixed point of t. Already in the statement we mentioned fixed points is a non-empty. I would like to choose a C is a one of the fixed point. Let us take it one more sequence of Pn. Applying the Ishikawa iteration scheme. I would like to write the Ishikawa iteration scheme as the inequality 7. And Pn is equal to constant. Applying of the by the definition of Russ. By the definition of that stability, we can write it to limit n tends to epsilon equal to limit n tends to norm Pn plus 1 minus alpha in Pn minus alpha in Tqn. It is tends to 0. Then we can say that Ishikawa iteration is a T stable. Because applying it scheme is iteration Ishikawa, therefore Ishikawa iteration is a T stable. limit uncertainty Pn equal to P, but limit uncertainty Pn equal to C. Therefore, it is a contradiction. Therefore, both fixed points are also same. Now it is an important theorem. Under the above hypothesis, once it is the Ishikawa iteration process is stable in the sense of Russ alpha. Once it is happens in Ishikawa iteration, the harder, then it is also in Russ also. Ishikawa iteration process is stable in the sense of Russ. So it is given here it is. But in this theorem statement, we can observe that if it is stable, then it cannot be Ishikawa iteration. If it is stable in the sense of Russ, kindly observe this statement here. If the iteration process is stable in the sense of Russ, then it cannot be harder also. Here it is I mentioned important this thing here. Now we can observe that Russ stability of Ishikawa iteration process does not necessarily imply the harder stability of the same. So once it is a Russ stability is a process is happened, need not to Russ harder stability will be same. I gave this example here. That is here it is mentioned in everything here. The Xn generated by Ishikawa iteration procedure 3 converges to 0 and 2. And if you are observing here, it is a mapping. 0 and 2 are two fixed points. Collection of fixed points of this mapping is a 2. One is a 0, second one is a 2. If you are taking any x0 in the initial value here, then it is converges to 0. And also mentioned here, arbitrary sequence of Pn 0 to 2 and epsilon, we are applying a epsilon is equal to norm Pn plus 1 minus alpha and Pn minus alpha and TQN. Limit intensity epsilon equal to 0. And possible cases I discussed here, that is the Pn is equal to semi-interval 0 to 1. And if you are applying Tpn equal to Pn by 2 and calculated some algebra conditions, algebra means mathematical simplifications, norm Pn plus 1, after calculating I am getting a less than equal to epsilon and 11 by 16 by norm Pn. This implies that the Pn tends to 0. Why it will be comes to 0 means that I applied the few slides back. I mentioned it's a lemma. I would like to show it now. This is the lemma. Once it is a lemma, we can apply this lemma. Now he applies here. Then with using of lemma, it definitely norm Pn plus 1, Pn minus Xn tends to 0. In the another case, if your Pn is equal to 0 to close interval 0 to 1 is also same procedure. With using of the same lemma, we are going to be tends to 0. Hence, in both cases also T follows the limit shadowing property. Thus, the Ishikawa iteration method is stable in the sense of Russ. Here we notice that the proposition 1, the Ishikawa iteration method is not stable in the sense of harder. So that means once Russ stability happens, need not be harder stability is also happened. But it is a need to happen also with using of some additional conditions. That is called the equivalence conditions I mentioned here. That is the equivalence analysis. Once a harder sense is also stable, automatically stable in the sense of the Russ also. For getting of this result, we need one additional hypothesis, sigma n is equal to 0 to infinity, alpha and beta n equal diverges. So now I would like to read it out this theorem. Then let K be a non-empty closed convex subset of a normal linear space X T is a self map on K to K. T is a self map that satisfying condition 6. So maybe participants may not be remember the condition 6. I would like to show to you. This is the condition 6. Norm Tx minus Ty less than or equal to norm x minus y plus phi of norm x minus Tx. This is the condition. That is the condition. Now we are applying here. That means of if and only if condition. So let us take it f of t is a non-empty. So in fact, that theorem is already proved in the previous also. Therefore, we need to take it f of t is a non-empty. Once it is a non-empty, I would like to choose the p is a fixed point. And choosing x0 is the initial value. And we are applying a Ishikawa iteration procedure. So I would like to write one line only. We can write it, show it here. Xn plus 1 minus p, 1 minus alpha in xn plus alpha in ty. I am copying here. Actually, Ishikawa is a two-step iteration. First of all, first line I am introducing. And after simplification of with using of simple mathematics, this equation is reduced to this format. In this format, here it is a third line. In this format, especially in this one, yn minus p is adjusted. According to the definition of Ishikawa iteration, I am expanding yn minus p value also. After expansion of yn minus p means that in fourth line it will be happened. Then do the simplification. Once it is simplified, after getting a simplification, we get to the conclusion of this condition 1 minus alpha and beta and delta into 1 minus delta into n norm xn minus p. Then we go for the simplification. Some iteration procedures, if you are applying, it will be reduced to this format. That is the pi times of k to 0 to infinity. 1 minus alpha k, beta k and delta into 1 minus delta norm x0 minus p. Then with using of the analysis techniques and with applying, it is the applying of sigma alpha and beta is a divergent. It is mentioned in the hypothesis also. Therefore, with the help of this divergence condition and simple logic and technical conditions to the real analysis topic, the last term is tends to 0. Okay, last tends to 0. Please just a minute. That's it. Oh, shit. There is some technical reasons. Okay. Okay, sorry for the inconvenience to you. This is some Reliance's text is using that will be converged to 0. If the Ishikawa iteration procedure 3 is a T stable, then theorem 1 is also mentioned that it is a stable in the sense of Russ. Similarly, you go for the inverse concept, converse, assume that Ishikawa iteration procedure is a T stable, is stable in the sense of Russ. Same procedure, same technique if you are applying, and we are going to be getting it 0. And also, let K be a non-empty set and reverse case also. This is also same. K be a non-empty is a closed convex subset of a normal space. X, T be K and T be a self map on K, satisfying the condition 6. And f of t is a non-empty. And alpha and beta and B two sequences are semi-interval 0 to 1. Alpha less than equal to alpha and beta less than equal to beta, and for some alpha beta greater than 0, then the Ishikawa iteration procedure is stable in the sense of Russ. Just the previous theorem, theorem 2 and theorem 3 is the variation is that in the above is the equivalence condition, sigma alpha and beta is a divergence, but it is not necessary. Here it is a alpha less than equal to alpha n and beta less than equal to beta n. If it is mentioned here, then we will get the convergence. We are not getting a equivalence here. So I would like to skip the proof of this theorem with the using of the previous same techniques I am applying here. We are getting the convergence here. And the conclusion that in this theorem, alpha n less than equal to alpha n, beta n less than equal to beta n. It is compulsory. If it is alpha n is a divergence, this theorem cannot be concluded. And I am providing an example also that is mentioned here. See this one here. The following example shows that the condition there is just a alpha beta is 0 to 1, such that alpha n greater than equal to alpha, beta n greater than equal to beta cannot be replaced by the condition sigma alpha and beta n equal to infinity. So if we are saying that this condition, we need to provide an example. Therefore, I provided one examples also here. I mentioned it as a provided available cases also with the two cases. This is the conclusion of the results. So due to the time schedule, I would like to conclusion of this talk. I think so maybe I gave a good information to you and provided literature also. And my intention is to provide the Russ and the harder stability. And the volume stability also need to discuss. We are at research is going on. Therefore, I am not having a concluding results. Therefore, I cannot provide it here also. So it is already communicated these results and it is under review. And those who have interested in this area for getting any information, you can contact me through email also. And I would like to close it to this talk now. And I'm providing a time to my dear audience. Please raise your questions. I'm trying to give answers to you. Sir? And this paper is also published. Sir, Namaste.
Namaste, sir.
Sir, I would like to give a time to the participants. If they have any questions and raising a hands, I'm trying to give a answers if possible.
Okay. Thank you very much, sir,
Sir,
for your lecture. Sir, is it over, sir?
it's just completed.
Okay. I want to ask some questions from
Because
the audience.
I would like to give a few minutes to the audience for giving a clarification if they needs.
Okay, sir. Definitely, sir. Thank you, sir, for your lecture on the stability of some fixed point procedures. This is the time for question and answer session because of huge participants. Any participant who is interested to clarify their doubts, please come forward to post it in the Q&A box. Sir will clarify the same. All the participants, those who are having any doubts, please post it in the Q&A box. Sir will clarify the same. Dear participants, any doubts, sir will clarify. Please post it in the Q&A box. Sir will clarify the same. Sir. Thank you, sir. Better.
There is a two possibilities.
So
One is most.
there are no questions in the Q&A box, sir. That's why I'm checking that is Q&A box. I want to check the chat box also, sir.
Sir, please. Go.
No, sir. There are no questions actually available in that Q&A box.
Okay, sir.
Okay, sir. Then structure that is. Once again, participants are requested. Any questions are there? Please post in Q&A box. Okay, I want to conclude that. Sir, thank you one and all for your good response and valuable support. Now I request Professor Dr. P. Vijayasarthi Garu to give special thanks to our today's resource person on behalf of the Department of Mathematics, Bapatla Engineering College.
Sir, good evening all. On behalf of the Department of Mathematics and the participants, I would like to express my heartfelt thanks to our today's resource person, Dr. Kot NVV Varaprasad sir, for his valuable presentation. In this presentation, Dr. Kot NVV Varaprasad sir has discussed about Russ and Harder stabilities of various iterative procedures associated with contraction mappings in different types of metric and normed spaces. These stabilities describe how small perturbations in the iterative process affect the convergence behavior of sequences generated by iterative schemes. By comparing these two notions, SAR has explored their interrelations and differences, illustrating the concepts through examples that demonstrate how certain iterative algorithms retain or lose stability depending on the structure of the underlying space and the nature of the contraction mapping involved. Today's session is really enriched with the presentation given by the resource person, Dr. Koti NVV Varaprasad sir, on the stability of some fixed point procedures for exploring the knowledge in teaching community. This session is very useful to the faculty members for strengthening their skills in function analysis applications. Thank you, sir.
Thank you very much, sir. Thank you very much for giving the opportunity to me, sir. And Karunakar Garu,
Thank you, sir, for your special thanks to our resource person.
Special thanks to the principal of Bapatla Engineering College, Ramadevi Madam, and Vijayasarthi Garu. Thank you very much for giving this opportunity. Sir, may I leave now?
So we will start our valedictory function.
Sir, may I leave?
Dear participants, please wait a few minutes. We will start our valedictory function. Sure. నేను చదువుతాను అశోక్, నేను చదువుతాను. ఓకే సార్, అట్లా అయితే చదివినాక అది మాస్టర్ వాలంటరీ స్టార్ట్ చేస్తాను. ఇప్పుడు సార్, ప్రొఫెసర్ సార్, ప్లీజ్ బీ అవైలబుల్ సార్. సార్, ఇది ఈ మెసేజ్ ఎప్పుడు 4:30 చదువుతామా మేడం పంపించింది? ప్రోగ్రామ్ సరే సార్, అట్లా సరే మాస్టర్ ఉన్నారు. ఓకే, సరే సార్. ప్రొఫెసర్ సార్, ఈజ్ ఇట్ ఆడియబుల్ సార్? ఓకే. వాలిడిటీ ఫంక్షన్ 4:30 స్టార్ట్ అవుతుంది. అంతవరకు ప్లీజ్ వెయిట్ చేయమని పార్టిసిపేట్స్ చెప్పేసి. Dear participants, validity function will be started exactly 4:30. Please be online. Please wait. Validity function will be conducted for exactly from 4:30. Dear participants, valedictory function will start at exactly 4:30. Please wait. Dear participants, validatory function will start at exactly 4:30. Please wait. A very warm and healthy good morning. Good evening to our principal madam, Dr. N. Ramadevi Garu, and convener, head Department of Mathematics, Dr. Kevil Acharyalu Garu, my dear colleagues and participants. Thank you one and all for your great support and tremendous response for this 1 week International Faculty Development Program. All the 6 days are engaged with 6 different lectures by the eminent resource persons. Many participants are actually participated in all sessions and interacted with our resource persons to clarify their doubts. We are thankful to them for spending their precious time to deliver their beneficial lectures. Now I request our convener and head Department of Mathematics, Bapatla Engineering College, Dr. Kevil Acharyalu Garu, to give his message.
Good evening to all. I extend a warm and heartfelt welcome to our beloved Principal Madam, Dr. N. Ramadevi Garu, beloved resource person, Dr. K.N.V.V. Varaprasad Garu, and esteemed faculty members. We gather here today through online to participate in the valedictory function of our International Faculty Development Program. It is with a great pleasure and a sense of accomplishment that I came here before you to deliver this convener's message on this auspicious occasion. Before proceeding to address the gathering, it is my bounden duty to express our special thanks to our esteemed resource person. Today's resource person, Dr. K.N.V.V. Varaprasad Garu from the Department of Mathematics, Guru Kasidas Viswavidyalaya, a Central University, Bilaspur, presented an excellent and insightful session. His clarity of thought, depth of knowledge, and engaging presentation style not only captured our attention, but also enhanced our understanding of functional analysis and its application. Thank you very much, sir, for your valuable lecture. In view of birth anniversary celebrations of Dr. Komaravolu Chandrasekharan Garu, Dr. Nagalla Prabhakar Rao Garu, we have successfully conducted this international FDP with enlightening lectures given by revered resource persons Dr. P.V. Sundaranand Garu, Dr. C.B. Pavan Kumar Garu, Dr. G. Srinivas Rao Garu, Dr. N. Fandikumar Garu, Dr. J. Bhaskar Babuji Garu, Dr. K.N.V.V. Varaprasad Garu. With this FDP's journey of growth, learning, and collaboration, which cultivates a spirit of continuous improvement with acquiring new knowledge. I am thankful to all participants for their interest to attend this FDP and made it a good platform for professional growth and continuous improvement in innovative teaching methodologies. When we put a proposal for conducting this FDP to our beloved Principal Madam, Dr. N. Ramadevi Garu, our Madam has been giving her valuable support, marvelous encouragement, and timely cooperation to us for conducting this FDP in an effective manner. Thank you very much, Madam. In particular, we are all thankful to our magnanimous management for their continuous support and encouragement for conducting useful programs for faculty members as well as students in view of enhancing the knowledge with emerging trends in education. You all know that these type of programs can be succeeded only with the teamwork, seamless coordination, meticulous planning, and collective efforts. My team members, co-convener Dr. T. Srinivas Rao Garu and staff coordinator Sri Nadan Karunakar Garu have given their full cooperation to me along with the support of staff organizers Ms. I. Rajeshwari Madam and Ms. K. Sunita Madam and also other faculty members in our department. I would like to thank Dr. K. Manideep Garu, Head Department of AML, and Institution Innovative Council President Sri M. Lilin Babu Garu, Faculty of ECE, and IIC member Sri P.V. Kodesar Rao Garu, Faculty of MCI Department, and Sri U. Venugopal Garu, who extended their timely technical support to us for making this event a fruitful one. The aim of this program is fulfilled and became a fruitful one only because of our esteemed participants. I express my sincere appreciation to each and every participant for their active participation and valuable collaboration for all these sections to make this program a grand success. Expecting the same response in our future endeavors also. Thank you. Thank you, one.
Thank you, sir, for your valuable message. Now I request our principal madam, Dr. N. Ramadevi Garu, to give her valuable message.
Dear participants, due to some administrative work, Principal Madam is unable to attend the valedictory function. Madam has sent the message I am conveying on behalf of the Principal Madam. Respected Convener, Dr. KVLN Acharyalu, esteemed resource person, Dr. Koti NVV Varaprasad, distinguished faculty members, organizing team, and dear participants. It is with immense pride and joy that I stand before you today at the valedictory function of the International Faculty Development Program on Innovative Applications of Mathematics, that is IAM 2025. Over the past 6 days, we have celebrated not only the birth anniversaries of two great mathematicians from the soil of Bapatla, Professor Komaravalu Chandrasekharan Garu and Professor Nagala Prabhakar Rao Garu, but also the enduring spirit of mathematical inquiry and innovation. I am delighted to share that today's session witnessed 733 participants with 396 joining through Microsoft Teams and 337 through YouTube live stream. This remarkable turnout is a testament to the relevance of our theme and the collective enthusiasm of scholars across India and beyond. It shows that mathematics continues to inspire, unite, and empower us in diverse ways. Throughout IAM 2025, I think every participant to learn from eminent resource persons who enriched all the participants' knowledge with their expertise and has left a lasting impact on our participants. I extend my heartfelt gratitude to all distinguished resource persons for their valuable contributions. I take this opportunity to extend my heartfelt gratitude to our convener, Dr. Acharyalu, whose vision and dedication have steered IAM 2025 to success. I also extend my heartfelt gratitude to faculty coordinators and organizers who worked tirelessly behind the scenes, and to every participant whose active engagement has made this program truly memorable. As the principal of Bapatla Engineering College, I assure you that we will continue to foster such platforms for knowledge sharing, collaboration, and innovation. Let us carry forward the spirit of IAM 2025 into our classrooms, research labs, and institutions, ensuring that mathematics remains not only a subject of study, but a tool for transformation. Thank you all once again for your presence and participation.
Thank you, Dr. T.S. sir, for your presentation of Dr. Sri, our principal madam, Dr. N. Ramadevi Garu. Now, I request the participants, please give your valuable opinions about this International Faculty Development Program, Innovative Applications of Mathematics, IAM 2025. Now, first, I request Dr. Praveen Kumar, Assistant Professor, Department of Mathematics, Srinidhi University, Hyderabad, to give his opinion on Faculty Development Program. I request Dr. Praveen Kumar. Is unmuted. Mr. Praveen Kumar, please unmute your mic. Praveen Kumar, please unmute your mic. Praveen Kumar, sir, are you available? Praveen Kumar, sir. Now I go for the next participant. Now I request Kavita Mani, Madam, Associate Professor, Department of Science and Humanities, Hindustan College of Engineering, Coimbatore, Tamil Nadu, to give her opinion on this faculty development program. Now I request Dr. K. Kavita Mani, Madam, Associate Professor, Department of Science and Humanities, Hindustan College of Engineering and Technology, Coimbatore, Tamil Nadu. Madam, are you available? Then please unmute your mic and start give your opinion about the faculty development program.
Sir, madam is available, sir.
Madam, please unmute your mic. Please wait, madam. Unmute. It is already unmuted for all the participants. Please unmute your
Sir,
mic.
good evening.
Madam, please.
Yeah, sir. Sir, good evening. This is Dr. K. Kavitamani from Hindustan College of Engineering and Technology, Coimbatore, Tamil Nadu. So each and every session was very, very wonderful, sir. Very excellent. We are very admired, and the time keep up. Everything is very good. Thank you so much, sir. Thank you very much. It's a fruitful FDP program, sir.
Madam, thank you very much, madam, for your kind words. It means a lot to us.
Thank you, sir. Thank you so much, sir.
Now I request Mr. Aditya Singh, Lecturer, Department of Applied Science and Humanities, Institute of Technology and Management, Gorakhpur, Uttar Pradesh. I am requesting Mr. Aditya Singh, Lecturer, Department of Applied Sciences and Humanities, Institute of Technology and Management, Gorakhpur, Uttar Pradesh. Please give your opinion on this faculty development program. Please unmute your mic and please express your opinion on this faculty development program. Now I go for the next participant, Dr. Chillara Somasekhar, Associate Professor, Department of Mathematics.
Aditya Singh sir is available. Please check it, sir. I think sir, from our side we have to unmute his audio.
Sir, it was unmuted for all the participants, sir. They have to unmute themselves and they have to express their opinion. From our side, it was unmuted, sir.
Sir.
Okay, once again I will call it. Sir, Mr. Aditya Singh, Lecturer, Department of Applied Sciences and Humanities, please express your opinion on this faculty development program. Okay, next one is Dr. Chillara Somasekhar Garu, Associate Professor, Department of Mathematics, Mallaridi College of Engineering and Technology, Telangana. Now I request Dr. Chillara Somasekhar Garu, Associate Professor, Department of Mathematics, Mallaridi College of Engineering and Technology, please express your opinion on this faculty development program. Sir, if you are available, please unmute your mic and express your opinion, sir. Now I request Ms. Pavitra M, Assistant Professor, Department of Mathematics, Hindustan College of Engineering and Technology, Tamil Nadu. Please give your opinion on this faculty development program. Now I request Ms. Pavitra M, Assistant Professor, Department of Mathematics, Hindustan College of Engineering and Technology, Tamil Nadu. Please express your opinion on this faculty development program. Madam, if you are available, please unmute your mic and express your opinion on the faculty development program. Now I request Dr. Mamta Kumar, Assistant Professor, Sahasra College of Engineering, Bihar. Now I request Dr. Mamta Kumar, Assistant Professor, Mamta Kumari, Sahasra College of Engineering, Sahasra, Bihar. If you are available, please unmute your mic and express your opinion on this faculty development program. Now I request Dr. Manikarao. Now I request Dr. Manikarao Sadravavulu, Lecturer, Department of Mathematics, GVSM Government Degree College, Olavapadu, Andhra Pradesh. Sir, if you are available, please unmute your mic and express your opinion on the faculty development program. Manikarao garu, GVSM Government Degree College, Olavapadu, Andhra Pradesh. Now I request Dr. Sudhakar Yadav garu, Assistant Professor, Department of Mathematics, Sri Venkateswara University.
Mic unmute చేసాం సార్ యాక్సెస్ ఇచ్చాం అందరికి చేసాం ఇందాక క్లోజ్ చేసి ఉంది ఇందాక స్టార్టింగ్ లో అందరికి ఓపెన్ చేసాం అందుకనే అమ్మాయి మాట్లాడింది తమిళనాడు అమ్మాయి
University of Delhi, Delhi. I'm requesting Dr. Sudhakar Yadav garu,
ఓపెన్ చేసాం
Assistant Professor, Department of Mathematics, Sri Venkateswara College, University of Delhi, Delhi. Please express your opinion on this faculty development program. Sir, if you are available, please unmute your mic and express your opinion on this faculty development program. Okay, now I request Omkar, Academic Advisor, Department of Computer Science, Willington College, Sangli, Maharashtra. Rushali, Omkar.
Good evening. Yes, sir. Yes. Good evening, everyone. I first want to congratulate and heartily thankful of organizing team of this 1 week international faculty development program by Bapatla Engineering College, Bapatla. I must admit that it is a very systematic organization of FDP. I joined this FDP to acquire some basic knowledge about recent development in application of mathematics for my PhD work. And I am thankful to the organization team that I will get the valuable information through this FDP. I wish all the best to organization team and thank you once again for this wonderful organization. Thank you, sir.
Thank you, madam. Thank you very much.
Madam, we sincerely thank you, madam, for your valuable response and encouraging words.
Thank you so much, sir.
This is Chinara Somashekar. I'm audible, sir.
Yes, yes, sir. Please carry on, sir. Thank you, sir.
Sir,
Please.
good evening
Hello,
to
sir.
all.
Dr. Sudhakar Yadav. Hello, I am audible, sir.
Sir, 1
Yes,
minute,
sir.
sir. Somasekar
Sir,
sir is speaking, sir. Please wait few minutes.
Sir, I am Dr. Sudhakar Yadav. Due to, sir, we muted, I could not speak, sir, about this.
Please complete it, sir. Please move.
Sir, this FDP is very useful for all of us. I hope such type of FDP would be continue in the next few years, so that faculty would learn many and interact to each other. Thank you, sir.
Sir, thank you, sir, for your warm appreciation.
Now I request Mr. Raja Venkatram V, Assistant Professor, Department of Data Science, Mallareddy University, Telangana. Now I request Mr. Raja Venkatram V, Assistant Professor, Department of Data Science, Mallareddy University, Telangana.
Yes.
Please give your opinion on this faculty development program.
Yeah, this is brilliant. I'm very much privileged to attend such kind of international FTPs, and the knowledge gained for all the sessions is a very much of expressive and qualitative knowledge sessions. It's good to conduct this kind of international FTPs further in future also. I'm thankful to everyone giving such an opportunity.
Thank you, sir.
Now I request Mr. Sunil Kumar, Assistant Professor, Department of Mathematics, Vidya Vihar Institute of Technology, Bihar. Now I request Mr. Sunil Kumar, Assistant
Hello.
Professor.
Yes, sir.
Correct, sir.
Good afternoon. Good afternoon, all respected dignitaries, organizer, and fellow participants. I am Sunil Kumar from Vidya Vihar Institute of Technology, Bihar. I am honored to get golden opportunity to reflect on this FDP over last few days. This FDP has enhanced my understanding of many aspects of mathematics, and it also improve and sharpens my skill as a teaching faculty. I like to thank and show gratitude to resource person who made every session interesting and engaging. I look forward to apply the knowledge gained here in my future teaching journey. Thank you, sir.
So thank you, sir. Your valuable response and kind words are deeply appreciated, sir. Thank you very much.
Thank you, sir.
Thank you, sir. Now I request Dr. Anand Kumar Mishra. Dr. Anand Kumar Mishra, Assistant Professor, Department of Mathematics, Digvijay Nath Postgraduate College, Gorakhpur, Uttar Pradesh.
Hello, sir.
Yes, it is
Thank you
audible,
so
sir.
much for organizing such a wonderful FDP program. I am very thankful to join this golden FDP program. Thank you so much, sir.
Thank you, sir. Now I request Mr. Madhavi Lata Ravinutala. I request Ms. Madhavi Lata Ravinutala, Assistant Professor, Department of Mathematics, Vasareti Venkatadri International Technology University, Andhra Pradesh. Madam, please unmute your mic. Please give your opinion on this faculty development program. Madhavi Lata Ravinutala. If you are available, please unmute your mic and give your opinion on this faculty development program. Now I request Vibhavari Tukaram Dokrat, Assistant Professor, Department of Mathematics, KTHM College, Nasik, Maharashtra. Sir, are you available, sir? Then please unmute your mic and give your opinion on this faculty development program. Tukaram ji, when you are available, please unmute your mic. Now I want to go for the next participant.
Yes,
Miss,
sir.
Madam,
Yes,
please.
sir.
Sita Lakshmi, madam. Okay, madam. Carry on, madam. Please give your opinion, madam. Madam, Vibhavari Tukaram, please unmute your mic. Now I request Miss Sita Lakshmi P, Assistant Professor, Department of Mathematics, Bharat Institute of Higher Education and Research in Chennai, Tamil Nadu. Please give your opinion on this faculty development program. Sure. Now I request, madam, please unmute your mic and give your opinion.
Good evening, sir. I'm audible.
Sita Lakshmi, madam, please give your opinion.
Good evening, sir. First of all, I would sincere thank to the organization of the IT arranging this 6 days activity, sir.
for all the resource persons who have shared their valuable and knowledge of experience insights of interest. Shorter section will give a more useful.
Now I request Mr. J. Chandra Reddy. I request Mr. J. Chandra Reddy Garu, Assistant Professor, Department of Mathematics, Sri Venkateswara College of Engineering, Tirupati. Please give your opinion on this faculty development program. Please unmute your mic and express your opinion, sir.
Good evening to all, sir.
It is audible, sir.
Good evening,
Yes,
sir.
I am T. Jayachandra Reddy, Assistant Professor at Department of Mathematics, Sri Venkateswara College of Engineering, Tirupati. I am very glad to be a part of this FDP. The sessions are very highly informative and well organized. So each resource person delivered valuable insights that truly enrich our knowledge and teaching perspectives. And I sincerely appreciate the efforts of a Department of Mathematics, Bapatla Engineering College for arranging such a fruitful and collaborative learning platform, sir. Thank you, sir. Thank you once again for giving this opportunity, sir.
Thank you, sir. Thank you very much for your valuable response.
Now I request Dr. Vinod Kumar Garu, Associate Professor, Department of Mathematics, Guru Kasi University, Punjab. I request Dr. Vinod.
Good evening to all of you.
Please,
Hello.
all the
Good evening,
remaining participants, please unmute your mics. Dear participants, please your mics.
Dr. Vinod Kumar,
If you are not
Associate Professor at the Department of Mathematics. Hello.
Sir, please carry on, sir.
Okay. All right. I'm Dr. Vinod Kumar, Department of Mathematics, Guru Kashi University, Talwandi Sabo, Punjab. I have all the session of this FDP are very informative, and especially I thanks to her day in which Professor discussed SIR model for epidemic diseases. These are very yes, sir. Patikumar ji. So this session is very fruitful for me because my research area is the same. So thanks to all of you, and overall all the sessions are very informative. So thank you so much, sir.
Thank you, sir, for sharing your valuable response.
Okay.
Now I request Dr. M.V. D.N.S. Madhavi Garu, Assistant Professor, Selection Grade, Department of Mathematics, Siddhartha Academy of Higher Education, Andhra Pradesh. Please give your opinion on this faculty development program. Now I request Madhavi Madam, Assistant Professor, Selection Grade, Department of Mathematics, Siddhartha Academy of Higher Education, Andhra Pradesh. Madam, if you are available, please unmute your mic. Okay, I want to go for the next participants. Now I request Dr. Kumar Rajiv Rajan, Assistant Professor, Department of Mathematics, Vidya Vihar Institute of Technology, Bihar. Request.
Hello, good evening, sir. This is Madhavi, sir.
Yes, ma'am. Please, ma'am.
Good evening, sir.
Thank you.
Hello. Good evening, sir.
Madam,
this is Madhavi,
please.
sir, from Siddhartha University.
Madam.
Am I audible, sir?
Yes, it is audible, madam.
Am I audible, sir?
Yes, ma'am.
Am I audible, sir?
Madam, your voice is very clear. Please go ahead, ma'am. It is audible, ma'am. Madam, it is audible. Please give a response.
Now I request Dr. Kumar Raju Rajan, Assistant Professor, Department of Mathematics, Vidya Vihar Institute of Technology, Purnia, Bihar. Please give a response on this faculty development program. Now I request Dr. S. Padma Priya. Now I request Dr. S. Padma Priya Garu, Associate Professor, Department of Mathematics, Mahendra College of Engineering, Tamil Nadu. I request Dr. S. Padma Priya Garu, Associate Professor, Department of Mathematics, Mahendra College of Engineering, Tamil Nadu. Please give your response on this faculty development program. Now I request Mr. Rajamahanti Surya Kiran, Faculty, Department of Engineering, SVP College of Engineering, Andhra University, Visakhapatnam. Rajamahanti Surya Kiran Garu, Faculty, Department of Engineering, SVP Engineering College, Andhra University. Please give your opinion on this faculty development program.
Sir, I think my voice is audible, sir.
Yes, sir. Yes, sir.
Sir, thank you. Thank you for giving me this opportunity, sir. I would like to express my sincere gratitude to the organizers for conducting such a wonderful and enriching international workshop on mathematics throughout this entire week. The sessions were insightful, well-structured, and truly inspiring, offering valuable learning opportunities from global experts. Your dedication, meticulous planning, and seamless coordination made this workshop a memorable and highly impactful experience for all the participants. Thank you for your outstanding effort and commitment to the academic excellence. Here is an enhanced thing. I would like to say that the workshop sessions were very much simplified, specified, standardized, and diversified for every one of us to understand. So hence, I would like to extend my heartfelt gratitude to the organizers for hosting truly a wonderful and intellectually enriching week-long international workshop. The sessions, randomness, SQL for security, applications of linear algebra, basic statistics, and optimization were very delightful. Behind disease transmission, automated theory in machine learning, and all the stability of some fixed point procedures were exceptionally insightful and broadened our understanding of diverse applications. Thank you once again for giving me the opportunity.
Thank you so much, sir, for your encouraging words.
Today's session concludes with a vote of thanks by Professor.
Sir, 1 minute, sir. 1 minute,
okay,
sir.
Okay, sir.
Karunakar, sir.
Okay, sir.
If anyone is interested to give your valuable response, please come forward, sir.
Hello, this is Chiller Somashekar, Dr. Chiller Somashekar. Am I audible, sir?
Yes, sir. Please, sir. Yes.
Good evening, sir. Good evening to all the dignitaries of 1 week international FDP on IAM 2025. I attended all the days of this FDP program. All the eminent professors of the FDP were clearly explained about the topic concerned, and all the points were completely noted by me. The conference gives me the complete information about the essentials of security, applications of maths, epidemiology, machine learning, and today's class about the topic concerned. I feel these topics are nowadays very crucial and essential for the research scholars, in particular for them to carry out the research completely. I am very much happy to be a part of the knowledge gained through this FDP. My sincere thanks to the principal, BEC, convener, Acharal Sir Garu, co-coordinator, Srinivas Rao Garu, and Karnakar Garu, and the entire team. Thanking you a lot, sir.
So thank you very much, sir, for your meaningful feedback.
Thank you, sir.
I am audible, sir?
Yes, sir. Yes, sir.
My name is Dr. Praveen Kumar from Serenity University. Good evening, everyone. Thank you for giving me the opportunity to share my experience of this FDP. Every speaker's lecture in this FDP is wonderful. 2 lectures today and 4 days covered the fixed point theory and the formation of SIR model along with the significance of R naught. Very useful for me. Reason is that because my research area is fractional order, mathematical modeling. That's why we are using both fixed point theory and R nodes. Overall, these FDP lectures have been mind-blowing. That's all my side. Thank you, Bapatla Engineering College. Thank you.
Thank you, sir. Thank you for your kind words and valuable response. If anyone is interested, yes, sir, please.
Sir, am I audible?
Yes, ma'am.
Okay, I'm Tilaka, professor from Venkateshwara College of Engineering, Sri Perambudur. At the very outset, I would like to congratulate the organizers because being on the other end, I know how difficult it is to organize an FDP, and the response has been enormous. And I also attended your FDP last year, and I was looking forward to attending this year. I would like to thank the thought that went into the conduct of this FDP. And as faculty, I'm sure all of us have benefited, not just from the research point of view, in the way we need to seamlessly integrate mathematics with other aspects of engineering so that students feel that mathematics is ML, it's AI, it's whatever they need. And I think your program has gone a long way in doing that for all of us. And many thanks to all the speakers and the organizers. And I'm looking forward to another FDP from your college the next year also. Thank you and congratulations.
Thank you, ma'am. Definitely, we will plan for another event shortly.
Am I audible, sir?
Yes, sir.
Good evening, sir. Good evening, everyone here.
Yes, sir.
It is a great honor for me to deliver the valedictory address for this faculty development program. Over the past few days, during the all sessions, we have gained valuable knowledge, explored new teaching methodologies, and discussed emerging trends. I sincerely thank the organizing committee.
మూవీస్ ర్యాంప్ ఎలా చేస్తారు వాళ్ళలాగా చేస్తారు హీరోయిన్ చేస్తుంటే మిస్ ఫ్రెషర్ వచ్చి ఎంఎల్ 17 అమ్మాయికి వచ్చింది మిస్టర్ ఫ్రెషర్ కూడా ఎంఎల్ 17 19 వచ్చినట్టున్నారు అది చూడలేదు నేను అందులోగా మళ్ళీ రష్ అయిపోతే బయటకు వస్తాను బాగా చేశారు డాన్స్ ప్రోగ్రామ్స్ కూడా అన్ని చాలా బాగా చేశారు
If possible, please unmute that one, sir.
It is actually.
Sir, please carry on, sir. Sorry for the inconvenience.
I sincerely thank the organizing committee, resource person,
I request all the remaining participants, please mute our audio because it is creating disturbance for us. Please kindly cooperate with us. I request all the participants to mute your audio because it is creating problem to us. Please cooperate with us. Sir, please carry on, sir.
I sincerely thank for organizing this type of faculty development program and institution for providing us with such a rich learning platform. My heartfelt gratitude to all participants for their active involvement, meaningful discussion, and collaborative spirit. I am very thankful to HOD sir, principal sir, and all organizing committee. Thank you, sir.
Thank you. Thank you very much, sir. If anyone is interested to give your valuable response, kindly come forward. If anyone is interested to give your valuable response, kindly come forward.
I'm audible, sir?
Yes, ma'am. Yes, ma'am. Please.
Thank you, sir. Sir, thank you, sir, for giving me this opportunity to join this wonderful session. This is my
first FTF session at this is was amazing. And learning for me a lot. Thank you giving for me. And I learned a lot from this. And it was truly enriching and learning experience for me. Thank you, sir.
Thank you. Thank you very much, ma'am, for your valuable response. If anybody is interested, please come forward to give a valuable response. Otherwise, we conclude the session.
Am I audible?
Yes, sir. It is audible. Please.
Am I audible?
Yes, sir.
Yeah, this is Balasubramanian from Taraganti, Karur, Tamil Nadu.
Sir.
Yeah, I think all the sessions are wonderful. It was neatly and clearly explained experts. My personal request is, please, for the next year, please do it in offline so that we'll have an opportunity to meet you all people.
Definitely, sir. Definitely, sir.
If not, at least for 2 days.
Sir. Definitely, we will plan it in the next year, sir.
Yeah, thank you.
Thank you, sir. Karunakar, sir.
Sir.
Please go ahead, sir.
Sir, today's session concludes with a vote of thanks by Professor Dr. P. Vijay Sarthi Garu.
So good evening all. Respected Principal Madam Dr. N. Ramadevi Garu, our beloved HOD Dr. Kevilan Acharli Garu, honorable resource persons, my dear fellow faculty members and participants, good evening all. It's my privilege to propose the vote of thanks to all who have helped us in making this FDP such a resounding success. First of all, I would like to express my sincere thanks to our management and Principal Madam for their constant encouragement and providing us all the necessary facilities for conducting this FDP smoothly and successfully. I would like to thank our distinguished resource persons, Dr. P.V. Sundaranand Garu, Dr. J. Bhaskar Babji Garu, Dr. Koti NVV Varaprasad Garu, Dr. C.V. Pawan Kumar Garu, and Dr. T. Srinivasrao Garu and Dr. N. Fanikumar Garu for giving excellent presentations and making this FDP so interesting and meaningful. I would also like to thank our beloved head of the department, Dr. Kevilan Acharli Garu, for his constant support and valuable guidance throughout this FDP. I am happy to express my sincere thanks to all esteemed participants, our faculty members who have made this FDP a grand success with their cooperation in all the aspects. I would like to thank Dr. K. Manideep Garu, Head Department of AML, IAC Convener Sri Lenin Babu Garu, EC Department, IAC members Mr. P. Kotesrao Garu, Sri N. Kirankumar Garu, Head MCA Department for conference arrangements. Sri U. Venugopal Garu, who extended their technical support in conducting today's program. Last but not least, I thank all the participants who have turned up in such a great number from different institutions across the country for attending this FDP. Thank you, Aranda.
Thank you, sir.
Thank you so much, everyone.
Thank you. You are all informed that feedback link will be shared to in both WhatsApp group and YouTube channel. And you have to submit 2 feedback forms. One is for today's feedback, and the total, that secondary feedback is for the complete program that is called 6-day program. Please fill it on or before 6 p.m. today. You are requested to fill the complete feedback in time. Thank you. Thank you, one and all.
Thank you, sir.
Thank you. Thank you, one and all.
Thank you, sir. Thank you very much. Thank you, sir.
Thank you, ma'am.